So now we're going to be talking about the vertical shift, or what makes this graph go up and down. Now you may say, oh man, I hope this is as easy as the phase shift, and you'd be right. In fact, it's even easier than the phase shift. Because instead of something going on inside of it, if we look at our equations here, we have a plus k that's happening on the outside. So a tangent of b theta should be here. Now, I do know that there should be a plus or a minus h on the inside of there, but they didn't write that, which is a mistake. But you have plus k on the outside. The plus k just tells us how much up and down this goes. If you notice the difference of notation here, the examples, y equals sine theta plus 4, there is no parentheses around the theta plus 4, which means that this is sine of theta as a thing, and then you add 4 on top of that. So, how does this work? Well, the easiest way to really identify where the graph is vertically is with the midline. Because remember, the midline, as we have always drawn it so far, is right at 0. So that means that if the graph goes up or down by a certain amount, the midline will move exactly that amount. So we're going to be using the midline in a lot of these examples. Alright, so we have this going on here. We have y equals 1/2 cosine of theta minus 2. So we want to identify everything that we possibly can about this function. We first want to find the amplitude. Now the amplitude has been the easiest thing so far because the amplitude is just going to be equal to the absolute value of a. Or another way we can say it is the amplitude is just going to equal 1/2 because that is our a value. Now our period is based on our b value. Specifically, our period is going to equal 2 pi divided by the absolute value of b. So what is our b value here? Well, I don't see anything multiplying directly towards the theta, so I'm going to say that the b value is 1. So in this case, my period will equal 2 pi over 1, or just 2 pi. Now, the phase shift is going to be based on what's happening on the inside of the cosine function. For instance, if I saw theta there, but I saw parentheses around it and then adding a number on the inside, I would say there would be a phase shift. However, there is nothing going on the inside. That -2 is on the outside of whatever's happening with that cosine. I would even put parentheses around the theta itself. Now you can definitely see that the cosine is only acting on the theta, and then the -2 is on the outside of that. So phase shift, we're going to say 0. There is no phase shift. Now the vertical shift is a little bit different. We see -2 on the outside. Now with the phase shift, it's the opposite of whatever we see. So if we see +2, we're going to the left, and if we see -2, we're going to the right. But with the vertical shift, and this is why it's even easier than the phase shift, it's just whatever you see. So if you see -2, that means it's going 2 units down. So vertical shift will say 2 units down. So the midline, now you're asking, where is the midline? So if the midline was at 0 and now it has gone 2 units down, that means my midline is going to be at y equals -2. The midline is going to be a line at y equals -2. So all you have to write, y equals -2. That is where your new midline is at. Now it's asking us to graph the function. So let's graph the function here. So we're dealing with cosine, so everything that we have done to graph these things normally take place the way it is. Now the first thing that we want to do is we want to identify where is our midline. Now everything that we've done so far, our midline has been at 0. So in this case, now our midline is at -2. So let's draw a midline at -2. So here we have a midline at -2. The next step is that we want the upper and lower bounds of our graph. So there we would look at the amplitude. Our amplitude is 1/2, which means that it's only going to go 1/2 above and 1/2 below our midline. Now, if this is the bounds of our graph, that means that this is going to be a little bit cramped, but that's all right. We can graph it anyways. Now, the next step is to identify the period. In this case, it's going to be 2 pi. So let's make a line at 2 pi. And you could put that line wherever you want. I would put it near the right edge of the graph. There we go. We have a mark at 2 pi. Now, what we want to do is we want to take our period and divide that in half and then half again. And that'll give us our full cycle and how that's going to look. First, I cut it in half, and then I cut the right side and then the left side in half. Now we want to identify what those pieces are. Now, a nice little cheating method that you can use to figure this out is just take our period, or 2 pi in this case, and divide it by 4. Now, what happens when we take 2 pi, divide that by 4? That's going to equal pi over 2. Now, that is going to be going on the first thing. So that's going to be our first point. Then you just add a pi over 2 for the next 2 slots. So pi over 2 plus another pi over 2 is 2 pi over 2, or you can just say pi. And then you add another pi over 2, and that is going to be 3 pi's over 2. Now we have everything we need to graph our trig function. So being that this is a cosine, we know that it's going to start at the maximum, then it's going to go down to the midline, then it's going to go all the way down to the minimum, and then it's going to pop back up to the midline, and then back up here to the maximum. And then you're just going to connect all of those points with nice little curved lines. Now, we are kind of cramped here, so I understand if this is difficult, but you should be able to get this semblance of a wave pattern. Good job. So let's try out the guided practice. Okay, so now we have our guided practice. So give this a shot, and you want to find everything that we did on the previous example. We're going to want our amplitude, period, vertical shift, and midline. On the last one, we were trying to find our phase shift, but as you can see, on this one, we also don't have a phase shift. So find those other ones. So first things first, we're going to want our amplitude. So our amplitude is going to equal the absolute value of A, which our A, since there's nothing in front of the tangent, is going to equal 1. So our amplitude is just going to be 1. Next up, we're going to find the period. Now, I don't see anything multiplying directly towards the theta, so I know my b value is going to equal 1. Now, my period, as you know, is going to equal 2 pi over the absolute value of b. So since b is 1, then my period is going to equal 2 pi. What is going to happen with my vertical shift? Well, my vertical shift is going to be whatever's adding to the whole thing, whatever my k value is. In this case, my k equals 3. So that means my vertical shift is going to be 3 units in the upward direction. So here we have 3 units up. Where is our midline going to be? Well, our midline is just going to be wherever it got shifted up to. So in this case, our midline is going to be at y equals 3. Now let's get to graphing. Now first off, we have not graphed tangent up to this point. Sine and cosine are very much like each other. However, tangent is not. There are some things that are going to remain the same. We are going to continue to use amplitude in a very different way. We will also use our period, but in a very different way. And there's the extra thing on top of that, that tangent looks very weird. I want you to, right now, pause the video, go to Desmos, and look up what tangent of theta looks like. And when you come back, don't be afraid, because it's okay. We will figure out how to graph these things. Now there is a reason why tangent looks so weird. I won't get into the philosophical discussion right now. I will just purely show you how to graph it based on these values that you have here. So the first thing, as we always do, is that we want to put the midline. Now our midline is going to be at y equals 3, so let's draw that out. So now what we're going to do is now we're going to put our lines for the amplitude. Our amplitude was 1, so we go 1 up and 1 down from the midline. So far, nothing different. And it even goes to the next step that we now want to measure out what we have for our period. Our period is at 2 pi, so we're going to make a mark at 2 pi, and we're still going to divide this up into 4 equal parts. All right, everything so far has been done the exact same way. So this is the part that it starts getting weird. With tangent, we're going to be doing something special with our quarter marking points. If you notice, we have pi over 2 and 3 pi over 4 being our quarter points. That's what I'm going to call them right now. And there, we are going to put asymptotes. Asymptotes. Oh man, what were those things again? Okay, so those were lines that the graph is going to get closer and closer to without ever actually touching. We usually signify them with some type of dotted line. We're going to do the same today. We're just going to make that dotted line the same color as our graph. All right, things look very hectic at this point, but now we can actually start to draw our graph. What we're going to do is that at our starting point, the place that our phase shift took us to, which there was no phase shift, so we are starting at 0, we're going to put a point at 0. We're going to put a point at all of our main intersections. So at 0, we're going to put a point at the midline. At pi, we're going to put a point at the midline. And at 2 pi, we're also going to put a point at the midline. Now, what does the amplitude do for us? Well, in between our point and that asymptote, there is going to be another point. So we're going to put another point between there and the asymptote. The first one we're going to put it on the top line. Now we're not calling this our maximum this time because the graph is going to do something a little bit different. We're going to call it just our top line. Here we're going to put a point on our top line. Now on the next between point, we're going to put it on the bottom line. And then we're going to put it on the top line. And then we're going to put it on the bottom line again, and it's just going to keep on going like that. At this point, you may think that you might know what the graph looks like, but remember, we have those asymptotes in between. The graph can never touch those asymptotes. So we're going to connect them with a curved line, but it's just going to go on forever upwards. So the first part looks like this. Just like that. And it's going to keep on going on and on, getting closer and closer to that asymptote, but without ever actually touching it. Now, on the middle section, it's going to start way down here and then curve up to that middle point. And then it's going to do the same thing that the graph did on the left side. And now, for our final bit of the graph, we're going to do the same thing as we did before. Kind of curve up to there. Now we have graphed our tangent. This is a periodic function, so this will continue and continue to repeat itself. For instance, going off to the left, we're going to see this curve down, and then it's going to do that thing again, and then that thing again, and then that thing again. It's just going to keep on doing this weird curvy bit. But for our purposes at the moment, this is all you have to graph. Please rewatch the video and really get a good sense of how you graph these things. Again, I didn't show you why we do any of the stuff or anything. That would be for next year when you are in pre-calculus. They'll show you exactly why these things are happening. But for right now, just know this is how you do it.